The allure of knowledge and the promises it holds have captivated humanity for as long as we've been able to think, walk on two legs, and learn to control fire. From the earliest cave paintings to the first songs ever shared, our species has always been driven to explore, create, and develop. As centuries and millennia passed, we evolved not only physically, but spiritually and mentally. After millions of years of evolution, humanity has reached its present stage of growth and understanding. Over time, we found answers to many questions that once eluded the greatest minds of history, the philosophers and scientists of ancient times. These mysteries have been gradually solved by the scientific community, one after another. With each discovery, fewer and fewer things seem impossible. Communication has become instantaneous. Diseases are being cured, and transportation, once slow and time-consuming, has become fast and efficient. Yet, despite these advancements, there's always a lingering question: when did time itself begin? If you're curious about the latest discoveries and news about our universe, don't forget to subscribe to our channel, like this video, and hit the notification bell to stay updated throughout history. Various theories about the universe's origin have emerged, and one of the most widely accepted is the Big Bang theory. According to this theory, the universe was once compressed into a single, infinitely small point. Over time, this point began expanding, stretching into the vast universe we now observe. It wasn't until later that the astronomer Edwin Hubble made a significant contribution by observing galaxies moving away from us. The farther a galaxy is, the faster it appears to be moving. This observation supported the theory of an ever-expanding universe. Hubble's findings showed that before the Big Bang, the universe consisted only of tiny hot particles mixed with light and energy. After the expansion, everything began to cool, allowing atoms to form. Over billions of years, galaxies formed and evolved, giving birth to the cosmos as we know it today. In 2021, the James Webb Space Telescope, JWST, the most advanced and costly telescope ever built, was launched into space. It works by capturing infrared light, which allows it to peer farther into space than any telescope before it. Positioned more than 1 million km from Earth, the JWST has an unmatched ability to capture images and process data. As astronomer Neil deGrasse Tyson has pointed out, the further the JWST looks, the further back in time it can see. Initially, the telescope was expected to confirm the Big Bang theory, but the first images it captured raised some intriguing questions. The first public images from the JWST showed galaxies that were small, smooth, and remarkably old, contrary to what many scientists expected. You might wonder how this challenges the Big Bang theory. Well, these observations have raised significant doubts about the model. For instance, in the JWST images, galaxies that should be farther away appear smaller in size, which contradicts the expectation that the farther away a galaxy is, the larger it should appear, due to the time it takes for light to reach us. Further discrepancies arise when examining how the galaxy sizes were portrayed in comparison to earlier images captured by the telescope. In the new JWST images, galaxies seem smaller, and some appear to have redshifts 2 to 3 times larger than predicted. One of the most perplexing images shows a large group of galaxies all appearing the same size, which raises questions about whether the universe is actually expanding at all. If the Big Bang theory is correct, galaxies should be smaller to account for the optical illusion of their distance. Additionally, some of the galaxies shown in the JWST images look surprisingly smooth. According to current theories, galaxies should collide and merge, producing galaxies with scars or distortions, a phenomenon known as mighty mouse galaxies. However, the images from the JWST depict galaxies that are unusually smooth, indicating that galaxy mergers may be much rarer than expected. These observations challenge the idea that galaxies grew large through frequent mergers. Moreover, the discovery of galaxies that appear to be billions of years old raises further questions. If these galaxies have existed for so long, they should have already been consumed by the cosmic process. According to the Big Bang model, the farther back in time we look, the fewer galaxies we should see, as older galaxies would have already disappeared. However, the JWST has captured images of galaxies that seem to contradict this prediction, suggesting that galaxies are more abundant and larger than expected. This leads to a critical question: could so many large galaxies have formed in such a short period of time? Many scientists find this highly improbable. However, there is an alternative theory, the plasma filamentation theory, that offers a potential explanation for these inconsistencies. The plasma filamentation theory, which has been around for over 5 decades, suggests that electric currents and the magnetic fields they generate attract plasma into filaments, which are found throughout the universe. Plasma filamentation has been recognized as a key process in the formation of stars, planets, galaxies, and other cosmic structures. When large clouds of gas and dust are pulled together by gravity, they can collapse, forming a protostar at the center. This collapse is sometimes aided by plasma filaments that help support the cloud, transferring energy and momentum to the gas and dust. Once a star forms, it may have a surrounding protoplanetary disk made of gas and dust, from which planets can eventually form. Plasma filamentation can influence the dynamics of this disk, although it is not directly involved in planetary formation. This theory also plays a role in efforts to create fusion energy artificially, a process that, while still in its early stages, may one day provide a significant energy source. Whether plasma filamentation will help us unlock the secrets of the universe or lead to a new understanding of its creation is still unknown. Time and ongoing scientific research will tell us more. It's possible that new theories about the universe's origins will emerge, but for now much remains speculative. As we continue exploring the mysteries of the universe and the origins of everything we know, one thing becomes clear: the pursuit of knowledge is a never-ending journey. Our understanding of the cosmos has evolved drastically over the centuries, and each new discovery opens up more questions than answers. While the Big Bang theory has long been the leading explanation for the beginning of the universe, the latest findings from the James Webb Space Telescope have cast doubt on some of its foundational assumptions. These revelations remind us that science is not static, but rather a dynamic field that continually adapts in the face of new evidence. The James Webb Space Telescope, with its unprecedented capabilities, has provided us with images that challenge many of the assumptions scientists had about the early universe. These images show galaxies that appear older, smaller, and smoother than expected, an observation that defies the conventional understanding of galaxy formation. If the universe is indeed expanding as the Big Bang theory suggests, then galaxies should appear larger the further away they are, not smaller. This inconsistency has led some researchers to reconsider whether the expansion of the universe is happening in the way we have always believed. At the same time, the JWST observations of galaxy mergers, or rather the lack thereof, pose another challenge to the Big Bang theory. According to the theory, galaxies should collide and merge, leaving behind traces of their violent histories. Yet the smooth, undisturbed nature of some of the galaxies captured by the JWST suggests that mergers may be far less common than previously thought. This has led some scientists to wonder whether the early universe was more stable than the Big Bang theory allows for the detection of older galaxies that appear to be fully formed. Also raises questions about the timeline of galaxy development. The Big Bang theory suggests that the universe began as a hot, dense point that expanded and cooled over billions of years. During this process, galaxies should have formed gradually, with older galaxies being harder to detect, but the JWST has captured galaxies that appear to be billions of years old, raising doubts about how quickly these galaxies could have formed. Were they really the product of an ancient cosmic event, or is there something else at play? These findings have prompted some scientists to reconsider alternative models of the university virus creation, such as the plasma filamentation theory. Unlike the Big Bang theory, which posits that the universe began in a single explosive event, the plasma filamentation theory suggests that the universe was shaped by the interplay of electric currents and magnetic fields which guided the formation of galaxies, stars, and other cosmic structures. This theory proposes that plasma filaments, which are visible at all scales of the universe, could have played a crucial role in the creation of the universe as we know it. One of the most intriguing aspects of the plasma filamentation theory is its potential to explain the observed discrepancies in the formation and size of galaxies. According to this theory, the process of star and galaxy formation could have occurred in a more gradual, organized manner than the Big Bang theory suggests. Rather than a sudden, violent expansion, the universe may have evolved through a series of processes guided by the forces of electricity and magnetism. This could account for the smoothness of the galaxies observed by the JWST, as well as their surprising age. While the plasma filamentation theory is still a relatively young idea, it offers a compelling alternative to the Big Bang theory. It presents a universe that is shaped by more subtle forces than previously thought, and it could provide the key to understanding the true nature of our cosmic origins. However, like any scientific theory, it will need to be tested and refined as new data becomes available. As our ability to observe the universe continues to improve, we may find that the answers to these profound questions are more complex than we could ever have imagined. As we stand on the brink of these new discoveries, it is important to remember that our understanding of the universe is still in its infancy. We have come a long way from the early days of astronomy, when the stars were mere points of light in the night sky. Today, with the help of advanced telescopes like the JWST, we are able to peer deeper into space and time than ever before, but there is still so much we do not know. In the coming years, as we continue to gather data and refine our models of the universe, we may uncover even more surprises. Perhaps we will find that the universe is even more mysterious and complex than we can imagine. Perhaps the answers to some of our most fundamental questions will lead us to rethink everything we thought we knew about the cosmos as humanity continues its journey of exploration. One thing is certain: the pursuit of knowledge will never cease. We will continue to ask questions, seek answers, and challenge our understanding of the world around us. The future of science is bright, and we are only just beginning to scratch the surface of what is possible. So as we await the next wave of discoveries, we encourage you to stay curious and engaged. The more we learn, the more we realize how much there is still to uncover, and who knows, perhaps the next great breakthrough will come from an unexpected direction, challenging everything we thought we knew about the universe and our place within it. As we conclude this discussion, we invite you to share your thoughts and theories. What Do you think about the Big Bang Theory and the Plasma Filamentation theory? Do you believe that the universe is still expanding, or is there another explanation for the phenomena we observe? Join the conversation in the comments below, and don't forget to subscribe to the channel and activate the notification bell to stay updated on future content as we venture deeper into the complexities of the cosmos. We must remember that the questions we are grappling with are not merely scientific but profoundly philosophical. Our attempts to understand the origins of the universe, the nature of time, and the possibility of other forms of existence stretch the limits of both our intellect and our imagination. Every new theory, every groundbreaking discovery challenges the very foundations of what we once thought to be true. This journey into the unknown not only reveals the secrets of the universe but also highlights the very essence of our human condition, our relentless curiosity, and our drive to understand the world beyond our immediate surroundings. When we speak of the universe's beginnings, we are talking about a moment far beyond our comprehension. The Big Bang Theory posits that the universe began from an infinitely dense point, expanding outward to form everything we know today. This idea has shaped our understanding of cosmic history for nearly a century, yet, as we have seen with the latest data from the James Webb Space Telescope, the picture may be more complicated than we thought. The images and data that have been shared with the public challenge our understanding of galaxy formation, the expansion of the universe, and even the age of the galaxies themselves. While the Big Bang Theory remains the leading explanation for the universe's origins, it is far from a perfect model. The discovery of galaxies that appear older and more fully formed than expected suggests that the processes of galaxy formation might have been much more rapid than previously imagined. Could it be that the universe's expansion was not as gradual as we once believed? The data from the JWST suggests that we might have to reconsider our current models and theories about how the universe evolved over time. These findings point to the possibility that our understanding of the cosmos is far from complete if the universe did not expand in the way we thought. What other explanations might there be? One such alternative is the plasma filamentation theory, which suggests that the formation of galaxies and other cosmic structures was driven not by a singular explosive event but by the interactions of electric currents and magnetic fields. This theory provides an entirely different framework for understanding the creation of stars, planets, and galaxies, and it could potentially explain some of the anomalies observed in the JWST images.